Welcome to the course. We're going to start learning a little bit about weather this week, basically the monitoring of the weather, and just somewhat what weather really is. So what are some of the basic characteristics of the atmosphere and weather? If you walked outside today, what would you like to know about the weather? And that's really the essential question that we're going to ask throughout all of this course. And then what makes each one of those things you want to know? So, for example, I bet you want to know what temperature it's going to be today, or is it going to rain? Is the wind going to be very strong? All of these are things we're going to talk about and what each of them makes and brings to the table. So weather is just these variables such as humidity, cloudiness, precipitation, wind speed, wind direction. And meteorology is the study of the atmosphere, processes that cause weather. But one of the things to remember is weather is what is happening right now. So if you walked outside the door right now, you were experiencing weather. What happened 20 minutes ago was weather at that time. What happened an hour from now is a weather forecast. So what you are experiencing at this moment, weather is right now. Climate is conditions over a long term. They're basically average weather, but there's also climatology, which brings many, many things into the study of weather and the study of climate. It's gotten a lot more sophisticated through the years. You can access weather information anywhere, 24 hours a day, 7 days a week. There's tons of it out there. One of the things about weather is, in order to know what the weather is, if we said it is at an exact time, we got to understand that there are different time zones, but we want to know the weather at the same moment in time. So, for example, in the Pacific time zone, if it's 4 a.m. and I am looking at the weather, it's 7 a.m. in the Eastern time zone, but that is all one time as far as weather is concerned. Even though there are two different times, we're keeping it. So what we do is translate everything into Zulu or Universal Time. Zulu is basically 5 hours different than Eastern Standard Time. So, for example, a 7 a.m. weather is actually 12 noon or 12 Universal Time, 12Z. So, but everybody in the country, in the world then could be on at 12Z. We look it over the whole world to get the weather. There are several types of weather systems, basically two. High and low pressure, and then there are fronts that are connected to them. So we're going to discuss these in a whole lot more detail as we move along. Highs are pretty much can be associated with fair weather, not always. And they have a clockwise rotation. So they rotate like the hands on a clock. Lows have a counterclockwise rotation, and they're generally associated with some kind of bad weather. And you can see here on an image of that. Air masses. There are large quantities of air all having the same characteristics. So in other words, temperature and humidity are very similar in that air mass. And they originate over the poles, over Alaska or Canada. Some of them originate in the tropics, and some originate in the desert southwest of the U.S. or the desert regions. And where they originate is what they look like. So if you have an air mass that originates over the Caribbean Sea, for example, that air mass is probably going to be warm, it's going to be humid. If that a different air mass originates over Alaska, I bet that's a pretty cold, dry air mass. Not a lot of water up there. So you can see where these air masses originate, what they look like. Then we have fronts that separate these air masses, warm fronts and cold fronts. And basically all that means is if you have a warm front, warm air is moving into your area, it's going to be warmer when that front passes you. If you have a cold front, it's going to get colder when that front passes you. Weather is three-dimensional, and as you can see here on these pictures, these are three-dimensional drawings. They're not looking at one-dimensional. So that's another aspect. So moving along here, just basically describing the state of the weather. We want to know the maximum temperatures, maybe. Maximum temperatures usually occur in early to mid-afternoon. One of the questions you're going to be asked this week is why that might be. Think about it. The sun keeps shining all day. The sun keeps heating it up. When the sun sets, it's no longer shining, no longer heating the atmosphere. So that's the key influence for why the temperatures rise in the afternoon, even though the hottest sun is earlier in the day. Air pressure is another indicator of weather. Sky. Meteorologists love looking at clouds, and clouds are basically just groups of tiny water droplets or ice crystals, or sometimes they have a mixture of both. High, thin clouds in the cirrus usually are ice crystals, and that's what causes the clouds to look a little different from each other. Lower clouds are more water, they look a little darker. Fog is just cloud in contact with the ground, and stratiform clouds generally are sheets of clouds, all uniform in height, not very thick necessarily. And cumulus clouds are real puffy, looking like a thunderstorm here, cumulonimbus clouds. And the clouds can move in different directions. Again, I talk about three-dimensional atmosphere. So the clouds that are well up in the atmosphere might move one direction. The clouds that are closer to the surface might move in a different direction. It all has to do on the wind speed and the wind direction that's coming from them. So I wanted to show you just some current weather maps, what's going on in the weather today. So we'll start with a weather map. Notice large area of high pressure down over Texas right now. Low pressure up here over Vancouver, Canada. Another low pressure system off the East Coast. So basically look for L's and H's to define these on a weather map. But if you looked at the winds, and the winds are just little barbs on a station plot. And we're going to talk about station plots a lot in this course. Station plots are just what is happening at that location at that time. And this map was actually drawn at the weather at 15Z, which would be 10 o'clock in the morning Eastern Standard Time. So you're looking at a weather that was occurring all over the U.S. at that moment in time. One of the things, high pressures tend to have winds that blow outward away from the center of the high, even though they go in a clockwise rotation. And you can see here the winds are moving this way, which is like a clock, and around and around. But notice how they're moving outward away from the high pressure. Low pressures tend to have counterclockwise, move in the opposite direction, which is what you have with these. And the winds are trying to move in towards the center. And the same is happening up here. Really, some of the winds are really pulling in directly towards this low pressure system. So this is just an example of a weather map you're going to look at. Another thing we get is weather radar. And you can see here, this is where the rain's really occurring today over Washington State. Hitting the mountains here, lots of moisture coming in off the Pacific and running into the mountains and causing rain there over that area. And this is just a reflectivity. It's a great way for meteorologists to look at where the precipitation is falling, even where some clouds are. Sometimes it can pick up clouds. Finally, here's just a satellite image, and you can see Ohio stinks right now with a lot of clouds over your area. Also along the East Coast, I had a cloudy morning here. I live in Virginia Beach, which is down in this part of the world. And that low pressure off the East Coast brought clouds up along with it, and they're just now getting out of my area. But you can really see the motion of clouds on the satellite images here. And that big low that was wrapped up here in Washington State, you can actually see bringing the moisture well in from off of California with time. So this is just one image. It's called a geocolor image because it basically, if you were in space, this is what the clouds would look like to you. You can actually watch motions of clouds. We talk about clouds moving northward here. See this little strip here across Texas and into Louisiana? That's actually snow on the ground from where it snowed over the weekend. So we'll talk about more of this information later on here. Please let me know if you have any questions at all.